Hi, I'm Kent the Novice, and I needed to bend some 14 gauge cold rolled steel. Products on the market for $100 or less seem to have an 18 gauge capacity, so they wouldn't work for me. I've achieved my goal, but don't expect fine craftsmanship. Remember, I'm a novice. I found this great YouTube video on how to make a sheet metal brake. It will lead you through the construction steps, so I won't do that. Unfortunately, the video doesn't talk about bending capacity or part dimensions. My video will. I only had 14 gauge cold rolled steel on hand, but here's what my device can do. It can easily bend a 2-inch wide piece. It can easily bend two 1-inch pieces on top of each other, roughly equivalent to a 1-inch piece of 9 gauge steel. You notice that I specify width because width really controls how much force is required to do the bend. You can bend something fairly thick if it's not wide. I tried to bend an 8-inch wide piece and was lifting my small welding table off the floor. If my brake was attached to a well-anchored bench, I could have gotten it done. I put about a 6-inch wide piece in and bent it with a bit of effort, but it worked fine. You'll see here that I get a nice small radius bend with my tool. You also see on this piece that there's a minimum dimension to do an offset bend like this. It's basically the width of the angle iron you build the brake with. The angle iron I used was 2 inches on a side and 1/8 thickness. If I'd had 3/16 available, I probably would have used that. The tubing to receive the pry bars is 11/16 inside diameter and 1/16 walls. That's seeming to work okay. The bars themselves are 5/8 inch diameter, and I cut them 20 inches long. So if we look at the material, the first piece that makes up the unit, it's put on the front. It's a base for the metal being bent, and the way I've done it here is bolt through it for the clamping piece. The width of your bend, the max width, is going to be from the washer on one side of this 3/8 bolt to the washer on the other side, which in my case is about 20 inches. The length of this piece is 23 inches. If you look at the other side, you see the hinge there. I put in 4-inch hinges with 4 screws and 4 bolts. Whether I needed them, I don't know, but I wanted to be strong enough. Next, you see the red clamping bar. It's another piece of angle iron. It's also 23 inches, the same length as the base piece. And you can see there the holes that have been drilled in it to fit the 3/8 bolts. You really should probably drill a 1/2-inch hole so you've got a little slop there for when you tighten the thing down. The next piece is the bending piece. It again is the same angle iron. I made a novice mistake here and cut this about 2 to 3 inches short. You can see by the gap in the end that I had to cut a slot for the hinge ball, ball, and I didn't have enough room to close the gap. But I put some gussets underneath it, and I think it'll do the job. So the actual tube to connect the bar with was another novice mistake. I put it in on the wrong side of the inside of this bar, and you can see my novice welding job here. Once I realized it, then I cut another piece of tube and put it on the other side. Now, I could say I planned this ahead, because if you turned the whole rig upside down, then the extra tube would be the proper one to use and might bend a bigger piece without lifting up the table it's mounted to, because you're pushing down this time. Here's the assembled piece. The alignment and tolerances of the three pieces where they come together is critical to a clean bend. So I'm bending a 5/16 bar, and as you could see, the table wanted to lift up. I finally got it bent by standing on the bottom leg of the table. You see I put two bends in it here. It bends quite nicely, actually. It's just the mounting that's a little weak. So I hope this is useful to you. Obviously, it's not a polished presentation, but that's what I can give you. So enjoy. Bye-bye.